Hello, everyone. So, from today, we are going to start our project number three, and this project is related healthcare domain. We have seen so many problems related to healthcare, and the idea is to automate the task and the projects which are done related to healthcare are like early disease detection or classification. I have shared so many projects related to it where you have seen that I was doing either dengue disease detection or lung cancer, brain tumor, breast cancer. So I do find this healthcare projects interesting because there's a wide scope in such kind of projects. Obviously, it's related to your social concern, and we can give a solution for such problems. Okay, so our today's project is having the domain related to healthcare, and we have to perform predictive modeling. A data set which is given to us is a multi classification data for test results where we are having record of the patients and what are the test results for them that's available. We have to perform multi classification for it. Okay, so the data description is available with me for your better understanding. We are taking a healthcare data for applying machine learning deep learning task over it. And this data, though it's mentioned like synthetic, however, it mimics the real world healthcare data, which provides information like the patient details, admission information, test results, etc. Okay, and we are available with a feature in the dataset that we will be considering as a target feature that's called as a test result, which is having three possibilities: normal, abnormal, and inconclusive. Okay, these three, it's available. Fine. So if we explore our data more, I will be showing you the CSV file. There we will see these features. What are the entries present in these features? We will talk more about it. Okay. So the key features here are patient information, which comprises of the name of the patient, age of the patient, gender of the patient, and the blood type or the blood group of the patient. Okay. And we do have medical and admission information also, like what's the medical condition, any primary diagnosis, something like that, whether the patient is having like diabetes, hypertension, asthma, etc. The date of admission of the patient, when it is admitted. Okay, doctor responsible for the patient, like this thing, hospital name where the patient is admitted. Okay, room number, admission type, whether it's an emergency, whether it's an elective, whether it's an urgent, whatever. What's the admission type? And discharge date also. So here we are available with the admission date. We are available with the discharge date also. Okay, that means the date when the patient was discharged. What kind of medication was given to the patient? Like okay, aspirin, ibuprofen, Lipitor, etc. There are various medicines which are given for the treatment of the patient. So that's all mentioned here. Okay, and then here are the test results for it. The test during admission with possible values of normal, abnormal, or inconclusive. These are the target variables. We are having some financial features also available in the data that are like insurance provider and the billing amount. See, obviously, it's a big deal because what I know the culture that if a patient is admitted into a hospital, the billing starts, and that billing is too much high. So it may happen we are having the insurance. Okay, so the details of insurance provider also been available with us. Okay, and billing amount, the total amount billed for the healthcare services, that is also available here. Okay, these are the features which are present in the data set. Now let me share my entire screen and show you the data set to see what are the entries in these features. Okay, so here I am sharing my entire screen and we'll discuss over the data. Okay, this is my data. Okay, so the name, age, gender, male, female, blood type, A plus, B minus, A minus, okay, whatever be the blood type. Then medical condition, cancer, obesity, diabetes, etc. Okay, that was the medical condition. And with this medical condition, they are admitted to the hospital. Here is a date for admission. Okay, who was the doctor treating the patient? Okay, in which hospital the patient was admitted? Okay, insurance provider. Fine. So obviously, so these details are the relevant details which every like hospital do maintain a record in this format only. Okay. Then insurance provider, billing amount, how much bill?
Negative values are billing amounts.
In billing, negative value are the negative values are present. Have you seen that there are negative values in
Yeah,
the
yeah, sir.
billing?
Why,
Okay.
what is the reason?
So outlier, isn't it? Or is there anything which you can consider that insurance provider has provided the insurance, whether at the initial the patient has deposited some money, so isn't it like a refund? Okay,
Hmm.
is it like a refund that okay, this much amount is we have expected, but amount is coming which you have deposited is more, so we need to refund you something? There are two ways, there are two things which we can treat here. Either
But
they are an outlier,
regular
or
process.
either there is something that needs to be refund from the billing. Yes, yes, these are the two
In real,
expectations. Yeah, yes, please say.
in real the scenarios, it is not happening. It's a refund in
In real scenario, if it is not
hospitals.
happening, then they
How to
might
correlate?
they might be like an outlier, because the second option which I told is we should not have any negative bill. So if there is some prior that means the person is not paying anything, instead it has been getting returned for some particular cause. Okay, so if there is prior deposit, so the hospital is giving in return that okay, this we are returning, this much not expenses been happened in your treatment. Okay, so there is some initial deposits, they do take the initial deposit, then start the treatment. There might be some, see, practical scenarios, no sir, there are many possibility how a hospital is dealing with the patient, what are their norms. Okay, fine.
Hmm.
Okay, so this is what happens. Anyways, we'll check out in our EDA. Okay, it's a good point raised. Then room number in which the patient is admitted. I think there is no issue with that. Admission type: urgent, emergency, elective. Okay, this is the type of admission. So urgency, emergency depend upon how's the state of the patient. Okay, and either it will be an elective admission. Discharge date is there. Okay, just like admission, we are having a discharge date. Then we are having the medication for it, what treatment patient has been given. Then this is the final, the target: normal, abnormal, inconclusive. That means, in what is inconclusive? Are we are not able to decide? Are we not able to decide that we started the treatment, we kept the patient, we did all these things to the patient, and still we are not concluding what happened?
Doubtable.
Doubtable.
Discharge.
Hmm. So, like normal, that means the patient admitted, this is what the treatment done, and the result came to be us, the test came to be as normal. Okay, there's nothing, no need to worry, or fine. Result can be abnormal, that means okay, further treatment will be required. Okay, you have to continue the medication. Inconclusive, that means we are having a doubt. Okay, so in doubt position, it depends that what can be done next. This is in the doctor's hand. So this is certainly kind of a data available to us, and we're just treating this kind of data as a real scenario. We are having the values present in the data as we can see the object type values. That means entries in text format. Name we are having, gender, it's categorical. Blood type is also like a category. Medical condition is also category. Date of admission is, we'll see, it's, I think it's right now mentioned here in form of a date. That is, when we recognize it, it will be like an object. We'll convert it into date time format. This is again like text, this is again text. Okay, and if I say doctor name and the patient name for the analysis, no, it's not like relevant thing, we'll drop them ahead. Okay, only the thing which is mentioned for us to keep a track for the analysis is the age is important, gender is important, blood type is important, medical condition is important. Okay, date of admission and date of your when the patient got discharged, this is okay, that can be considered, and we can find that for how many days the patient was kept in the hospital. Okay, so that could be one of the factor which can help us in identify that okay, for 10 days this much bill, for 20 days this much bill upon this particular treatment. So we can have some insights related to that. Okay, admission type, we are going to keep. Room number is something. Okay, room number is better, that admission type will tell. Okay, if it is urgent, emergency, then obviously such kind of services, urgent and such kind of service, elective, such kind of services. Okay, room number is, I think, not. Bill is important for us. Okay, this is the initial perception which I'm making over the data. So when a data scientist work, okay, when the data scientist got a problem statement, so data scientist step number one, what it do is, okay, let me tell what it do is, this is how I approach. Okay, so today I'm going to talk about the approach also, what I do, and I expect the add-ons from your side. Okay, the first thing is, what's the problem statement? I need to know what's the problem statement. Okay, here I do talk about the initial details, that is the domain knowledge. Okay, domain knowledge I should have. I should be having a knowledge about the features which are present in the data, and what kind of entries which are present in the data. I should have a knowledge of them. Then only I can consider that okay, yes, you are a scientist person. Unless and until you don't have the knowledge of them, it will be like a challenging task. Okay, so with this details introduction, knowledge of all these things, then okay, what I need to identify, problem statement, what I need to identify, what is the question. This is the data available. I checked what are the entries present in them. What I need to identify, what's the task, what's the goal. Okay, Then the problem statement says that, okay, either you have to do regression, either you have to do classification, or any other tasks you need to perform. Okay, then the next things will come in my mind is how to solve it. How to solve it? So I have to make a layout. I know that what are the steps to execute a data science project. Fine, I need to take my data, I need to perform the EDA, I need to perform the visualization. Obviously, there are some parts of pre-processing been put up here. Okay, pre-processing. Okay, so that's what I need to do. Pre-processing, all these things now can be like, okay, somewhere at the as per the requirement you are putting in your analysis. Okay, then with this visuals, how what kind of insights I'm getting. Okay, and it may require that I can have some feature engineering also. If it is required, I can perform feature engineering. So all this stuff I need to apply. Okay, and this is the common layout of the approach. When you do this thing actually on your data, then only the things get clear. Okay, and then after that you will go ahead with the model part. What kind of models are good for my analysis to get the result? Okay, so corresponding, I apply the models, I select which one is the best here according to the scores, according to the evaluation, and the rest is the deployment part and other things. Okay, so how I approach to the problem is a way which I use in every code, every other code, and this is what I do. Now I'm showing you my code. Okay, so I know that what's the starting of the project, and I keep a proper theme so that I did not have to struggle. Okay, I add the title in my project. I add an image also. Yes, I'm doing some healthcare project, so I do add an image also in the project. So title and the image to give it. Then okay, the basic libraries: NumPy, Pandas, Matplotlib, Seaborn. Okay, basics. If you know anything in the data science, if you not knowing in the data science, okay, doesn't matter. Go ahead, because these are the base of the core libraries. Anyhow, somewhere they are going to be used. So don't think, just add. Okay, NumPy, Pandas, Matplotlib, Seaborn. Then okay, warnings. I want to ignore the warnings. Okay, so keep this thing, and now access your data. Okay, make a data frame, row column arrangement, and this your table data frame, like this kind of arrangement. Just access the data. CSV file is there. We are accessing. Then I applied head and the tail. Okay, first 5 rows and the last 5 rows of the data. So in my every project, you are going to see this thing. A follow up I do take in this way only, and this is the way because I'm available with a lot of codes present in my database. So it will not take, if you do the coding a proper style, if you follow, it will not take much time for you to do any other project, because the steps are known. Just use it. Okay, so tail, last 5 rows, then shape. Okay, how much my data is? So it's like 55,500. So data, I am having enough data to do the analysis. 55,500 is good. 15 columns are there in my data, and these are the columns. And we have already discussed about what the meaning of the column. Okay, so here in my code book also, I did mention about the columns, what they mean: name, age, gender, blood type, medical condition, admission date, then doctor, hospital, insurance provider, billing amount, everything I mentioned. What's the explanation? So it will be easier. And in your code also, you please follow up this thing. Okay, explanation of data set is something which is required. Okay, so just put it here. All right. And it has been told the theme of the project is to perform the predictive analytics, and the target is multi classifier. There are three classes there: normal, abnormal, and something which we can't conclude. So there are three classes present. It's a multi classification problem. Okay, so we'll be doing this data cleaning, transformation, visualization. We'll try to use this thing for predictive model. We'll try to build it. Okay, fine. So as I have seen here in the data, and it should be click in my mind. Okay sir, in data you are having so many object types columns, sir. You are having the column with patient name, doctor name. You are having like the terms related to the disease diagnosis. There are so many object type columns, sir. Are we going to one hot encode everything, sir? Because just in the previous project now we have seen, are you going to one hot everything? So I initially marked that okay, patient name, doctor name, room number in which they are admitted. So these are not this is numerical, but I'm saying that in general that these are not like my required terms, because the terms which are related to healthcare, okay, age, the kind of disease, okay, blood type, blood pressure, etc etc, these are important terms, we are going to consider them. बाकी इनका वन हॉट एनकोडिंग का तो ऐसे आई थिंक रिक्वायर्ड नहीं, ड्रॉप ही करो अननेसेसरी, वो बहुत लेंथ बढ़ जाएगा इन द प्रीवियस लेक्चर, इन द प्रीवियस सेशन वी हैव सीन, तो इनको रखने का कोई सेंस नहीं। देखेंगे अपन आगे एनालिसिस में, विल चेक आउट इन द नेक्स्ट, अभी देखते हैं। All right. So duplicated, there are 554, 534. So yeah, I dropped them. कोई सेंस नहीं बनता डुप्लीकेट्स को रखने का। Out of 55,000, I can drop 534 duplicates. No worry. There are no null values present in the data, so fine. If I print the information of the data, I found that okay, there are many object types. You can see, as I already telling, many object types are there. See, देखिए डेटा में when we are going to have a fair analysis, when we are going to have a fair analysis in the data, if we are having object types ना, many object types values, तो यहाँ पर क्यों मुझे डाउट लगता है, I do have a doubt if I am having many object types features present in the data, क्योंकि जो algorithms हैं, machine learning algorithms हैं, they always expect that we are looking forward to have a relationship, we are looking forward to find the relationship between the independent and the dependent variable. Okay, we are looking forward to identify the relationship between the features. And if we are having like object types, categorical values, so many categorical values like present, so in this particular case, identification of the relationship, what these x and y possess, that is something apart, which is like a challenging, that how I can be like to find, to identify the relationship between them. Because if I am using certain equation, y equal to mx plus c, if x is either 0 or either 1, for example binary in nature, okay, so just put the value of x 0, so answer is c. If I'm going to put the value of 1, the answer is y equal to m plus c. These are the two possibilities I'm getting. Okay. uh, and some data are very challenging data, and that's what now I got some insights, some suggestions from you guys also on the day one, that sir kindly take a data which is from the industry point of view, and which should have so many features, we are having the mix up of them, and sir we can look out for the deployment of the model, and there are many suggestions came to me related to it. Okay, the way you, okay, industry data is still a data, and the data will be comprising of what? Object type, numerical type. Anything else? Anything else do you expect in the CSV file? That will be available. So if you are having a knowledge about these things, obviously the same way you have to apply. The challenge will be like, okay, you are having so many null values, so decision making will be complicated there. Decision making in the industry data, what to fill, what not to fill, what to drop, how with whom I need to impute, and there could be certain challenges which we see that industry do have such kind of issues. Okay, so if you are good in tackling that, you are the scientist person. Okay, appreciated. Which feature important, what is not important, so the things will go from this way only. Now so many object types columns, what kind of result I'm expecting? If the data which is having numerical columns, many numerical column, that is something, a kind of a good data, which I believe good data to do the analytics. But if a data is having so many object type columns, analytics will like, okay, yeah, what to do. Okay, this is my perspective, which I as per my experiences. Okay, so we'll proceed ahead. Fine. Many object, few numerical description, that means for the numerical features, that is age, billing amount, and the room number. These are the three numerical features. So statistical values are printed for it: mean, median, mode, standard deviation, minimum, maximum, all these things are printed. Okay, fine. These are the unique values which are present in the data. So I am having this first number of unique values. Why it is important to print the unique values? Because I want to know, okay, gender, two values. Okay, because this will help me in univariate analysis. Like, okay, how many unique values are there? Gender is categorical in nature, count plot, pie plot. Blood type, categorical in nature, count plot, pie plot. Medical condition, count plot, pie plot. Insurance provider, count plot, pie plot. Okay, admission type, same. Medication, same. Test result, same. So whatever with the categorical, na, count plot, pie plot. Univariate analysis. For discrete, same. Count plot, pie plot. That will identify from here. Now, just separate object type and the numerical type. Yes, yes, Madhu. Ask the question.
Sir,
Hmm.
so let's say if a column is having unique values
Hmm.
which is equivalent to length of rows in the data set.
Hmm.
Okay, all the values are unique.
Hmm.
So how important that column would be for
What is that column? Is it
no, not
uh,
in this.
uh
In general, I'm
in
telling.
general I'm asking.
Hmm.
That means you are
Hmm.
saying that
That
we are having a
ID,
column. We are having a
Hmm.
column with all the unique values. Okay, all
Correct.
the unique values are okay.
serial
So
number or ID.
serial number or ID. Okay,
Yeah.
or it's not mandatory, sir. That's a good example given by sir, that okay, you are having an
Hmm.
ID that is having 1, 2, 3, 4, 50,000 unique values are present.
Hmm.
Okay.
Hmm.
Data collection of each instances.
So ID or just a serial number. If this is the case of data, what I did so far is I dropped this thing. What I did so far is I dropped this thing.
Okay.
Okay.
So yeah,
However, now
even
now there is
I.
another now there is another thing. If it is not an ID,
Hmm.
if it is not an ID, for example, there might be some like columns which don't have like all unique values, but that doesn't have the serial number. Okay, all are different. Okay, now we do consider as continuous feature. Okay, that is one of the continuous feature, and we do use the analysis of it. Like as continuous, we are going to make a histogram, dist plot, then box plot, volume plot, all kind of plot we are going to consider for them.
Okay.
Okay, we do use them. Okay, for
Hmm.
but in case of ID, okay,
Hmm.
serial number are not considered. Rest other than that, we are going to. It may happen that in this particular data also you are having a billing. Billing may have all
Hmm.
the unique values.
Okay. Hmm.
There's a possibility, and I'm going to do the analysis of billing by this way only, because it's
Hmm.
continuous. All these plots are preferred for it to be made.
Okay. So, okay, by plotting these plots
Hmm, hmm,
on this continuous series
hmm,
data,
hmm.
like what would be the inference out of it?
See, what the very much important, because continuous always say that very much important continuous features. That's why I told that
Hmm.
if you are having data like categorical or discrete, they are having only countable values. Continuous, it doesn't have countable, uncountable values. Okay,
Correct.
that's why we are putting it in a particular range. Okay, in
Hmm.
a class interval. Okay, class interval, and and by making histogram, they shows the distribution. By making dist plot also, they are going to show the distribution, that how many values are coming in what particular interval. And I already told that for a continuous we are having a one important kind of plot, that is a normal distribution. Okay, that is one of the preferred plot in statistics. Preferred in stats, we say that such kind of distribution for the continuous is going to help better in our analysis. And the models are also statistical models. Machine learning models are statistical models. So they do expect the kind of distribution of data to be like a benchmark distribution. Okay, to be like something related to it. However, it's not mandatory that you can transform a data into normal. It's not mandatory. Okay, just like in the linear regression, previous projects also, I told that you check the distribution of country is not normal, then apply log transformation over it. Apply log. Okay, but it's not mandatory that after applying log you will get the normal, but still we try to transform the data in something standard, which is expected by a model. So model expect that the distribution should have to be normal, like linear case. But in case of other algorithms, okay, logistic regression don't say, decision tree, random forest, they don't say that we are expecting this kind of data distribution with the continuous. Okay, support vector machine, it say that we have to scale the data. That's why you have to apply standard scaler. That is the expectation of support vector machine because it is a distance based algorithm. Okay, so there are expectation of the algorithms. Okay, however, if we keep the distribution of data feature clean. Clean means, what's a clean? Clean, that means something which is statistically
Yeah,
statistically
Balanced.
without
appreciated.
any
Huh.
outliers. Yeah.
That distribution is something recommended. So such kind of analysis will help me at all.
Okay.
Okay.
Got it, sir. Thanks.
All right. So that's an explanation. Fine. So here we are having object types, numerical types I separate. It's mandatory. In every project you are seeing such kind of code that you separate object type, numerical type, and then classify them. Which one is categorical, which one is not categorical. This is something, it will give you a clear idea. Okay, it will give you a clear idea. Okay, this is categorical, what I need to do over categorical. This is not categorical. Okay, non-categorical, what I need to do. Discrete, I don't have anything. Continuous, I have this thing. Okay, so all these codes, I follow the same approach in my every project. I identify what kind of data I'm having, and then I do the analysis. And I already told that for categorical and discrete, check what are the unique values present in them. Okay, so gender, male, female, blood type, these are the blood types, medical condition, this. These are categorical unique values. What are the value counts in them? Okay, gender male 27,000, male female something, blood type. So the distribution is also like appropriate here. You can see medical condition, insurance provider. So this is a uniform distribution, like I will say balanced. Okay, this is balanced distribution. Whatever be the entries which are present in the data, they are just appropriately balanced. Okay, you can see medication, test results, everything is balanced. So I need not have to deal with the imbalancing also. So for example, in most of the cases, the test results are imbalanced. Target imbalance hota hai. And then we have to apply smart type of algorithms to balance the data. Okay, then only we can apply the algorithms over it. So this is something which happens. Okay, अभी ये डेटा आपको मिला है, इसमें आपका कुछ प्रॉब्लम्स, कुछ इश्यूज रिजॉल्व ऑलरेडी दे हैव डन. They are giving you the balanced data. Okay, so all the categories are having 18,000, 18,000, 18,000 entry. So no issue for data balancing. Okay, and then I do make the count plot for them. And in a one go itself, for I in categorical, that means with a loop, I print everything. For all the categorical, just make the plot, counter plot, show them, annotated. Okay, annotations. So that the people should not have to visit, okay, these are the towers we are seeing, we don't know what is the value of the towers. So this is annotated a plot. Okay, so count plot for each and every categorical, and in a best way is to show the pie plot is I use plotly. Okay, here it is, plotly. For pi, I'm going to use it. Okay, to have a better representation, visualization, you can see. Okay, so plotly for the pie plot. Done. Now because I don't have any discrete features, so I'm done with the categorical univariate analysis. And then I proceed ahead with the continuous. That's a question, that's something which is very much important. Why continuous distribution? Because most of the data in the real life is continuous only. Mostly we are having a continuous kind of data only, and it is preferred. Today also, as I was teaching the LLM, okay, in which I was teaching the transformer architecture, transformer model. There is one important thing which happens in a transformer is word embeddings. And what I told, that every word is embedded with a vector that is having continuous values like zero point 0.1, 0.2. So continuous representation is very much important rather than we go with the discrete or countable values. Because in real world, the data, most of the features should have to be like continuous. That's why I told that initially, if your data is having like a object type and it is categorical in nature and looking forward for something, okay, what to do with that? If I transform this data, this categorical data, again one hot encoding and so many zero one, again the sparse. So such kind of data create issues. Sparse data will be created. Now what to do with the sparse? So many zeros are present. What kind of result you are going to get with so many zeros? It is not effective. But continuous, okay, I did not have to create any dummy. I did not have to do any one hot encoding. Nothing. Continuous will stand continuous. The thing, it requires a transformation according to the algorithm. If it is, then if not, then go ahead. Continuous is important. Okay, so here here you can see the histoplot for all the continuous features, and what we are seeing is none of them is normally distributed. Okay, they are not normal. I made histoplot, I made distoplot, I made the box plot to identify the outlier, because there is a question came, sir, in billing you are having the negative values also, because but I haven't seen any kind of outlier so far in the billing amount. This is the billing amount box plot, no outlier I can see. Okay,
Why, sir?
so you can see that there are no outlier present in box plot. There are no outlier present.
But negative values present.
Okay, so by making the box plot, the distribution is still fine, no outliers. See, room number is not at all important. Billing amount, that's something which is important. I can't see any outlier, neither on left, neither on right. You can see neither on age, no outlier. But I surely I agree with the point. There's a valid point that billing amount, if you are having negative, there might be some reason. I told that the reason will be, okay, are the medical institution, the hospital is returning something. Okay, because here the insurance and claim is also there. Okay, so medical or the hospital is getting from the money from the claim, and whatever be the patient deposited initially, that they have to return. So patient is not going to pay anything. Insurance will pay everything. Okay, if it is covered, and whatever initially the patient deposit, return it. Then only in admission got happened. Without money, who is going to admit?
It's an assumption only,
It's an assumption, sir.
not a reality.
Maybe, sir. Maybe, sir. Maybe that's what I'm assuming. Maybe. Okay, because it's not mentioned. And sir, in which rows you are getting the negative values? Okay, one more. I got some comment here. Okay, the outer fence on the box is below zero or the billing and should be removed in your opinion, because we don't know why. Okay, sir. Right now, I'm not seeing any like cutoff outlier consideration. You can see no point is present on either of the side. So my data is not having any outlier as per the distribution says.
Sir,
Yeah.
sir, so can we say that our negative and positive values both are equally
Hmm.
distributed?
Hmm. negative and positive both are equally distributed. How, like, okay, this is your billing count.
Identifies. Can you filter how many negative values, how many
Okay, fine.
positive
Let me
values?
filter it.
Ratios.
Okay,
Ratio.
fine. Let me filter it. Okay. So smallest to the largest, I'm going to. So did the
Percentage.
filtration, and there are many negative values are present. Okay, many
Many more, sir.
up to 100 negative values are
Magni-
there. 109,
Magnitude and the
108
values.
or 109 negative values are there.
Maximum negative.
Okay, these are the negative values present. 109. Then rest are all positive. Rest all
The
are
top
positive.
most.
Rest all are positive. Out of 55,000, 108 are negative. Rest all are positive. Okay, so our
It is
assumption is,
your nearest near to nearing because of values are
huh,
uh,
yes,
less no, so 1,200 rupees like 1,300 rupees will be returned from hospital to patient.
okay, so this is the scenario. 108 values are negative. Okay, and that's a good thing. And one more point I want to add: the kind of analysis which we are doing. If we are having numerical values, okay, if you are having numerical values, okay, kindly apply the procedure which has been suggested, that you do filter, because it may happen that right now you are seeing the values which are positive. However, by applying the filter, you will also get an idea, are there negative values present in your particular feature or not. So do apply the filter. Very good suggestion. Okay, this should be added in your analysis while working over the data, because billing cannot be negative. We are putting some assumption that, okay, is something returned to the patient, or like,
We separately we analyze as
uh,
negative value and positive value, like
uh-huh,
that.
so that can be something. Okay, we can consider. Okay, fine. Right now I don't have any outlier present in the data. Okay, then the next thing is, okay, I made box and plot also. That's an optional. Okay, box and plot. I like box. I made box and then violin plot also. Okay, and violin plot too. I made. Okay, fine. So univariate analysis I done for my continuous features. Then there are two things which I can do for the bivariate analysis. Okay, I can take the features, like, for the bivariate analysis, what I do is I make continuous versus continuous scatter plot and line plot. That's what I make. However, when I did draw continuous versus continuous scatter plot in a line plot, I haven't got anything. That means none of the continuous feature are related to each other. It was looking like a nonsense. Okay, there was no relationship between any of the continuous feature. We are having three continuous feature, all three are independent of each other. So then what I did is I made a bar plot, categorical versus continuous. That's what you can do. Categorical on x-axis, continuous on y-axis, and you can print the average values. Okay, like here. Male and the female, what are the average values for, like, gender versus age? This is very much important. So average value for male, average age for the male is 51.49, for female is 51.58. That's what you can do. Okay, categorical versus continuous, bar plot, box plot, wall in plot, all these can be done. Okay, this is something which we can get some information out of it. What are the average values for them? Okay, so all these average values are printed, categorical versus continuous. Okay, fine. All right. So you can see the details here, and it's up to you if you want to make a plot for some features, that also preferred. Here I'm using a loop and I'm printing everything. It's not mandatory to print everything. You can take from your side. I made box plot also, categorical versus continuous. Okay, it's not mandatory. It's just an optional. If you want to keep, you can. If you don't, remove. No, not a worry. So I made box plot. We can make Wallin also, Boxon also in this particular regards. Okay, so like I told, continuous versus continuous, scatter plot, line plot. Categorical versus continuous, bar plot. box plot, boxen plot, Boolean plot. That's you can make. Okay, that you can make. Fine. Um, yeah. Next is I haven't included that particular plot, but you can make categorical versus categorical also. Cat versus cat, categorical versus categorical bar plot. I haven't included categorical versus categorical, but the point is why we are doing these plots, why we are doing this visualization, what kind of distribution you are looking forward to identify. So that is important. If I think that I'm not getting anything out of these now, so there is no sense of making the plot. So visualization should give you something, and that's what I we identified. So main plots are like box plot and all these histogram to check the distribution. They are main. Okay, rest bivariate is showing the relationship to find the correlation between the feature. They are important. Rest average values printing by bar plot categorical versus that's okay, fine. So you have to decide from yourself. And then when I identified the correlation between the continuous feature, this is what I got in form of heat map. There is no correlation between any of the continuous feature. Nothing. I'm not going to find anything. Age, billing amount, and room number. Nothing. Okay. So this is the correlation matrix. Okay. It's negligible. Fine. And see, there are many aspects related to it for the correlation. Some people think that, okay, sir, can we do one thing? Can we convert categorical into discrete like 0 1 format something, and then can we find the correlation between them? Okay, there's you can do that. Okay, you can convert them into this particular format, that is like one hot encoding or like some label encoding. It has been 0 or 1, and you can find the correlation between the features, how they are. Okay. Uh, but 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 the point is I made scatter plot between continuous to continuous to identify the relationship. Okay, whether it is increasing or decreasing. The sense is like why you are going to make a or try to look out for the correlation between discrete and continuous. What you are expecting from here? Continuous versus continuous is okay. Discrete versus continuous correlation. What are you expecting that? Okay, discrete these two values 0 and 1. How they are going to behave with with continuous? So see, every time in data science, it's all about exploration of the data. Okay, so I do at my end, I do prefer that in my coding also I use continuous heat map. I made this because I need to identify between them. I didn't make scatter plot between like categorical versus continuous. Okay, if you make a scatter plot, it sense categorical versus continuous. If you make a scatter plot, now it will look like this: dot 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 on in this particular value, dot 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 on this particular value. Ultimately, the better way is just try to make a bar plot for them. Okay, that's it. So correlation continuous, no nothing. I printed, then I made pivot table. At least I need to find some good more information about the data. So I just use pivot table, and I request that pivot table is something that you have to include in each and every of your project. Okay, so I made the pivot table. I put gender, medical condition, and admission type on the index. Okay, these three I put on the index, and billing amount and age on the column side. Okay, billing amount and age on the column side, and I'm looking forward for mean values. Okay, so here you can see gender, medical condition, and admission type. These are on the index. So female, medical condition, this admission type is selective. What is the mean age? ये pivot table na, pivot table is something which give you internal of the like uh, internal values, or like statistical point of view, it is very much important. Okay, so female having this medical condition, elective admission type, this is the mean age. Either you can choose mean, or either you can choose max, min, whatever, it's your choice what you want to choose. Okay, so here I printed the mean. Asthma, how much? Cancer, how much? Diabetes, how much? Hypertension, obesity, for male female both, what kind of disease they are having, what kind of admission they are having, and what is the age, and what is the billing. Average bill, how much they paid for that. These all details are mentioned. Either you can use mean, either it's better you can use max or the mean also. You can have another pivot table also. Okay, then again I made a pivot table, like I took only billing amount, and I took insurance provider and the test results. Okay, so this is the insurance provider and this is the test results. The billing amount is this. Okay, you can include other parameters also. Okay, insurance provider, or rather you can use gender also here. Okay, gender, test results, what is the billing amount, and what is the age. You can include. You can make pivot table as flexible as you are. Here the aggregate function I'm taking as sum. Previously I took mean. Now I'm taking sum. I can take sometimes max, min, or whatever. Sum, average. I can take anything. Depend what kind of insights are important for you. Okay, I can take multiple aggregate function also. Here I'm taking medical condition and the gender. Okay, so medical condition are arthritis, gender female, billing amount is this. Okay, mean billing amount is this, sum of the billing is this, and overall count for the values for bill is this. Okay, so it's up to us. I can increase this billing amount, and I can have age also here. Okay, so that's what we can make as a pivot table. Room number also. Okay, however, that's not something which I do prefer. Okay, room number, but it's I put here in the code. With room number also you can make a pivot table. Room number, admission type, insurance provider. Okay, fine. I did group by also. Okay, again, just try to have a similar kind of insights, but not with a pivot. I just use group by. Okay, fine. So, gender and the medical condition. What is the billing amount and what is the age? I'm just considering the mean of them. I could have done this with pivot table also. So this is group by. So group by operation, pivot table, these are important in pandas. Okay, group by this to have some good values for the data frame in terms of mean, median, mode, and all these things. Okay, fine. So I did group by also. Huh. And why I'm doing this thing now again? Let me tell you. Initially, when I started my project, I told that I'm having so many object type values. So what I can do with this so many object type values? These are the things which I can do with so many object type values. Okay, I am having continuous only billing and age which are relevant. Room numbers ignore. So only those these two continuous I am having, age and the billing. Rest all like object type. So how I can utilize the object type? What kind of information I can get from the object type? Okay, like okay, so that's what I did using making pivot table, making group by to find the mean bill, to find the sum of the bill for this disease, this gender, and this test result. This is what I can do if I'm having so many object type, especially categorical. So remember, okay, such kind of insights you have to include in your project. Okay, here also I did the group by. I can do the group by admission type, median value, standard deviation. Like, these you can keep as for your reference, and you can change from your side. It's up to you. All these things you can change from your side, and you can include. However, I have included many of the codes here for your help. Okay, So all these group by and pivot table information I have collected. Mean, sum, max, min. I can do. Okay, then I was having date of admission. So let's convert it into date time format. And here it's not like that there is a one patient and we are daily basis monitoring the condition of a patient. So it's not a time series issue. Uh, it's not a time series issue. We are having so many patients and they are having different admission date and different like dispatch dates. Okay, dispatch I will say okay, they are been free from the hospital, so they are having different dates. So it's not like time series issue. So I converted date of admission into date and the time, and I collected day, month, and year from it separate. What's the day? What's the month? What's the year for the admission? Similarly, I did this thing with the discharge date also. I did with this thing also. Okay, what is the day? What is the month? And what is the year? Fine. That too also I did. Fine. So I created few more columns. This can be considered as a part of feature engineering. That means creation of few more columns from the existing features. Okay, this is something called as a feature engineering. I did that. Okay, then the thing is, I dropped the name, date of admission, discharge date. I think we should add further more in this particular code. Okay, that means doctor name can also be dropped. Okay, fine. Drop doctor name, and what else you think that can be dropped? Hospital name can be dropped. Insurance provider can be dropped.
Room number.
Yes, room number can be dropped. Okay, fine. So name, admission date, discharge date, then room number can be dropped. Okay, fine. And what else can be dropped? Okay, doctor, na? Yeah, doctor. Okay, let me put doctor also. Okay, doctor also dropped. Okay, what about hospital and the insurance provider? Hospital and the insurance provider.
That also not relating to the model.
That just related to your is it giving anything related to the target?
Not,
That
no,
is your
no,
test result. Are they contributing to the test result? Do you think?
no, because it's not related to biological parameters. That's why
That's
we
not a biological parameter. Okay,
Sir, room
it's
number.
result is depending upon biological parameters.
result is something test result, because this will be our target for the multi classification. So if they are not like biologically related, so insurance provider,
Preferably, we priority first given to the biological parameters.
our
I
priority should
think
be biological. Yes, yes, you are absolutely right. If you want to talk about what is the like the result, test result,
mm,
normal, inconclusive, or abnormal, they are not like related to the insurance provider or something like that. Okay. However, then what about the billing amount? Billing amount is also not biologically related. Okay, they are also not. But if the question was something different, that if you need to identify what will be the billing amount, then might be you have to keep the hospital and insurance provider in concern. Okay,
okay.
if you have been asked that predict what is the rupees, how much you have to pay, billing amount. If this could has been target, so this is continuous in nature. So might be like hospital and insurance provider could be in concern. But right now, if you are having a problem, that is your this thing test results. They are not biologically related. Yes, anything.
Sir, room number.
Route number we are dropping. Yes, I suggest that we have to add the admission duration. Okay, discharge date, admission date. That will be better correlated in the billing. Sir, actually, now we have already divided. We created this admission day, admission month, admission year, discharge day, discharge month, and discharge year. These we have added. Okay, so if we are keeping this in our analysis in your model development, we can do that. I just want to ask what to do with
Sir,
hospital. Yeah.
may I comment?
Yeah.
So if you subtract the duration, if you calculate the duration time
Mhm.
from the time that they were
Okay. That
admitted,
Okay.
then you know how many days they were in the hospital,
Huh.
and that's going
Okay.
to correlate best with billing.
Okay. So we can have like this DF, DF days. Okay, days we can do, and we can include here the admission date and the discharge date. So discharge, okay, control C, this is the discharge date minus this is the admission date. Okay, that is the date of admission. All right, fine. So yeah, we can identify how many days the person was present in the hospital. Okay, so that's what we can find out. Okay, however, my code is already executed, so I'm just keeping all your suggestions here. Okay, that's what I am putting. Let me run this thing. Will it give me, okay, if it has been dropped from this DF, then it will throw an error. Okay, discharge date. There is an issue with the discharge date also. Okay, what kind of issue it is having? Let's again refer to the values. So date of admission is 31/1/2024. Discharge date is okay, 2/2/2024. Okay, pattern is same. Okay, so it should have been followed this thing. It must have followed this thing, and the difference needs to be right. Okay, fine. Okay, then it should have to be fine. Discharge date minus date of admission, then it should give you the total number of days the patient present in the hospital. Okay, might be because I've already executed my code. I have some other things also. So if the column was dropped, then it is throwing the error. Okay, so it's just throwing an error of the discharge. But I'm keeping as per your concern you told. Now, any other thing which you want to drop or you want to include? So hospital and insurance provider, shall we drop? Shall we drop these two? Keeping in concern related to the test results, we drop. Okay, so let me drop it. Okay, what's the final? Okay, okay, no. Why no? Yes.
Sir, we can get it some information whether the person is insured or they paid the bill by their cell phone.
हाँ ये तो है. That's what we can keep. But sir, you know one thing, insurance provider, that's a long range of values. So you will be having so
Yes,
many columns if you do perform the one hot encoding. So not every detail for every insurance provider is not important. Similarly with the case with the hospital. Okay, that has also been there.
we can get it the related to
Information, sir,
information
that is fine,
related
sir,
to.
that we are getting here, and we have already used them for the okay, we can use for our prior analytics. But putting this thing into a model will give you a long range of values, and they are not at all like any biological help, they are not giving in test
Yes,
results.
yes, that is.
Okay, so sir, if you want to classify that whether the patient is normal, inconclusive, or abnormal, okay, we will talk about the medication. We can talk about the admission type. Okay, we can talk about the age. We can talk about what is the initial status of the patient. But sir, keeping these two, if we are looking forward for billing amount prediction, then might be they are important. But right now, sir, our
Yes, yes,
problem is different.
yes, yes.
Okay, so sir,
Okay.
hospital, I'm including here, but I will not run this code because it will throw again an error. Okay, hospital and insurance provider. Okay, insurance provider. Okay, that's what I'm doing. Fine, fine. So I think these columns are like enough for us right now in this particular moment to perform the analysis. Okay, fine. So far we have done all these things, and next will be like doing the modeling part and rest of the analysis. So we'll follow this in the next class. Meanwhile, let me reshare the screen with only the code. Okay, fine, let me stop the recording. All